Okay, so now let's go on to example 4. So in these examples, we're asked to calculate a bunch of logarithms where now the exponent is unknown. So in this first example, we're asked to calculate log base 3 of 1 over 27. So because the part after the equal sign is not written in, we can just write in that it's equal to x. Okay, so as usual, to think of the log, we think of it in terms of the exponential form, right? So what is the exponential form? It's the base raised to the exponent is equal to this thing. So I've written it out here. And so to be able to work out the exponent, essentially what we're doing is what power should I raise 3 to obtain 1 over 27? Okay, so you have to think that 27 is the same as the 3 to the third power. And because the 3 to the third power is in the bottom, you can think of it as being 3 to the minus 3 power. Right, so 1 over 27 is the same thing as 3 to the minus 3 power. And so if I put that in, now the bases are the same. Right, so because the bases are the same, that means the exponents have to be the same. So that means the x has to be minus 3. Okay, so the idea is to write into exponential form and try to match the bases to figure out what x is going to be. So let's try to do that. Right, so again, let's put in that it's equal to x. And then in exponential form is the base raised to the exponent. So 6 to the x is equal to this thing. So it is equal to square root of 6. So how do I write the square root of 6 as an exponent? Well, the square root means it's to the 1/2 power. Right, so this means that 6 to the x is equal to square root of 6 again is 6 to the 1/2 power. Right, so the bases are matched. And so that means the exponents has to be the same. So x has to be 1/2. Okay, so let's continue. So again, we write in that it's equal to x. So the base raised to the exponent, which is this thing, is equal to the thing in the parentheses, which is 7 to the 1/4. But for this one, when we've written it out, the base is already matched. So that means that x has to be this thing. So x is equal to 1/4. Okay, so when the base is like this, we want to write it into exponential form and try to figure out how to match the bases. In the next few examples, because we have the common logarithm and the natural logarithm, and these are available on the calculator. For these, if you want, you can just enter everything into the calculator. Right, so like for example, this is the common logarithm of 1000. Well, what is the common logarithm is this operation here. So we just enter in common logarithm of 1000. And what do we get? It's equal to 3. Similar for the next one. Common log of 1 over 100. Whoops. Common log of 1 over 100 is equal to -2. And even for the natural log, we have the natural log on the calculator. right? So natural log of e to the 1/5, natural log, e is here, to the exponent 1/5 should be in parentheses, close parentheses, close parentheses. So natural log of e to the 1/5 is 0.2. But 0.2 as a decimal is the same thing as 1/5. So let's see again, where this calculation is coming from, right? So natural log means the base is e. We're trying to figure out what the exponent is. So what is it in exponential form? E to the exponent, so e to the x, is equal to this thing. So the bases are matched, and so x has to be 1/5. Okay, so let's continue. Next one, ln of 1 over e to the 3rd power. Ln 1 over e raised to the 3rd power is equal to -3. ln of 1, we know this has to be 0, right? Because log of 1 is always equal to 0. But if you don't remember the rule, again, you can just put into the calculator, natural log of 1 is equal to 0. Okay, finally, e to the natural log of the square root of 3. Okay, so there's a few ways you can think of this. Right, so e to the natural log of square root of 3 is 1.732. But suppose we want an exact answer instead of a decimal answer. So how else can you think of this? Right, so we can say this is equal to x, and because this is in exponential form, we switch the log form instead. So what is log form? It's natural log, right, because it's base e, and what goes in the parentheses, it's the result, right? So x, and it's equal to the exponent, right, which is natural log of square root of 3. Right, so the exponent should go here, and the result should go here. And so now the logs are matched. So that means these two things have to be the same. So x is equal to the square root of 3. And you can see that the square root of 3 is exactly this decimal value. Another way to think of it is that, as we said, the natural log and exponentiating with the base e is inverse to each other. And so when you're applying anything in its inverse, they should cancel out. Right, so you should get back the original thing. So x has to be equal to square root of 3.